Hello guys, and welcome to another video to our YouTube channel. Once again, I'm Rhiannon and this is my dad, Nick.
Hi guys, and welcome to Science Sidekicks. I'm Nick, it's my sidekick Rhiannon, and we're exploring science experiments and stuff that we can do at home in our kitchen, right?
Yep.
So if you've been following along, thanks. Don't forget to like and subscribe if you haven't already. It really helps, and all of the followers and everything that we have really makes Rhiannon happy and keeps her motivated to want to keep showing up and doing these videos, right?
Yep.
Okay, so in the last video, we made our own battery. And what did we use to make our own battery?
Lemons and salt.
Lemons, salt water, and what was the other chemical? Hydrogen?
Hydrogen dioxide.
Peroxide. All right, so we used a voltmeter and we used our wires to make a circuit that we powered from the batteries, right?
But
that we made ourselves.
You can see there is also another meter.
Yeah, now we have another meter here. This is an amp meter, okay? So this is going to tell us the number of amps that we're using. This tells us the amount of voltage. And if you remember from our last lesson, we were talking about voltage and amps from our power generator, okay? So voltage is always going to remain the same. If we set the voltage here, the circuit will have the same voltage everywhere. The amount of amps that we're using will change depending on the amount of things that we have connected to the circuit. And that's what we're going to demonstrate today, how our amps, or the amount of power, changes with the number of items that we have connected to the circuit, okay? So the first thing we're going to do is make, again, our basic circuit that we've got here, which is a series circuit with a switch. So what have we got in this circuit, Rhiannon?
We have a voltage meter, we have a switch, a amplifier,
amp meter,
and a light.
And a light, okay, and they're connected together in series. Now, because the terminals on this are not the right way around, it looks like they're crossed over, but this is actually correct. If we were to connect the output of this to here, you can see it would be black to black, which wouldn't be correct, right? So we had to go black to red. If we were to do that, then we would get a negative reading on our amp meter. It means that it thinks the current's flowing in the opposite direction. So everything's connected up here. All we need now is our power source. So here we have our power source. This is a variable voltage and amperes power source. So we can set the voltage with the top number. If we turn this here, you see that changes, and we can choose the number of volts that we're going to have. And down here, we can choose the maximum amount of amps, the maximum amount of power that this will allow out of it. So we're going to set this to 1 amp, which is the most power that it will allow out, okay, for now, and 1 volt. And then we connect this up to our circuit. So we've got our positive power in and our electric there, okay? So we've got a positive and negative connected up, and if we push this button, what do we see happen? Nothing. Why might that be?
Because it is...
You want to touch the plastic bit. Close the circuit. Okay, push that down. Excellent. So now the light bulb is on, but it's not very bright, is it? And that's because we've only set this to 1 volt, and we can see on our voltmeter here and our amp meter, we're not using a lot of power, we don't have a lot of voltage, and that's why our light bulb is not very bright. Now we can change that by increasing our voltage. So if we put this up to, let's say, 2 volts, our light gets brighter.
Yeah.
And the amount of voltage we're using should match, okay? So our voltmeter is now reading 2 volts, and over here, our amp meter is also starting to show that we're using some power here, okay, some amps. Now, it also shows us on our digital readout here, we're using 0.18 amps. Now, we set the maximum amps to 1, right? So effectively, at 2 volts, this light bulb is using 0.18 amps. We've got more light bulbs here that we're going to connect up. Now, what do you think is going to happen when we connect the next light bulb up? If we don't change anything here, we leave this at 2 volts,
This light will get smaller to put more power to this light.
Right, that's a good idea. Let's see if that's what actually happens. So we'll turn off our power, open up the switch, and we'll connect this one up. Okay, so we've now got two light bulbs here connected up in parallel.
Now
We haven't changed anything here. We'll turn on our power.
Let's see how it looks.
Let's see what happens now. So, we've still got 2 volts, but we're now using 0.43 amps. Because now we've got 2 of these connected. But it's not dimmer, is it? You thought it might be dimmer.
Yeah.
The reason is because we've connected these together in parallel. If we were to put this in series, then it would be dimmer. So let's remember this. We've still got 2 volts, and we're pulling 0.43 amps. Okay. Now let's change this so that the light bulb is in series instead of parallel, and we'll see what effect that has. If we put this back down to 2 volts that we had at the beginning,
this one will become small.
You see? They get dimmer, right? If we put this up to 3 volts, so what we've had to do to get the same brightness as before, we had to increase the voltage to pull the same amount of current, okay? So if we leave this voltage the same now, and we connect one only, now what do you think is going to happen? So we've got 3.5 volts, and it's going to the light bulb on its own. It's very bright now, right?
Very.
It's very bright, and we're pulling 0.26 amps. So all of that power is now going to this one bulb. But when we have the 2 in series,
they're gonna need to share it.
They have to share it, exactly, right? Sharing is caring. And what we're doing is caring for the light bulbs. Because actually, the light bulb doesn't like glowing too bright, because when it glows too bright, there's a chance that the filament might break. So with the same voltage, with 2 light bulbs, we're pulling less power, and each one is less bright. Okay? So that's the difference between series and parallel circuits. So this is in series, because it comes one after the other after the other. But when they were connected in parallel, where we were using the extra wire, and we had it coming off like that, then they were both equally bright.
Yeah.
Okay, so we're trying to figure out now why
this light bulb is not sharing with the other ones.
But it is. But you just can't see it. Now, if we increase the voltage here, that one's going to get very bright. Now, look what's happening to the others. They're getting a little bit of power here, okay? What's going to happen, though, is if we crank up this too much, we're going to blow this bulb, okay? So we don't want to put too much voltage through there. But what's happening is this light bulb is taking all of the power that it can, and there's hardly anything left to pass on to these, which is why, even though we've put these ones in parallel to this, they're barely lighting up. I don't know if you can make it out on the camera, but they've got a very, very, very dim.
This one has a little bit more light than this one, though.
Yeah, it's got a little bit more, but all of the light's going here. Then it wants to take all of the power for itself. So the best thing to do would be to put them all in parallel. And once you do that, they're going to share the power between them, and it's not going to be all taken by one. All right, so now we've got 3 bulbs, all in parallel with a switch at the beginning. We'll connect up our power to this. Because we're powering them in parallel now, the switch is now not part of the circuit. Or is it? That's causing a short when you put the switch like that. So the switch should not be wired in parallel like this, because that causes a short. When we close this, all of the power wants to go through there.
Dad?
So that's not how the switch should be connected in a parallel circuit.
Dad,
Yes.
Did you realize that here it's still a little bit more
bright than the
bright
others.
than the others,
It
but
could
the
also
others
be
are still bright.
Could also be because the bulbs, I don't think, are all exactly the same.
Yeah,
Some of
that's
them from
why.
this different
That's
kit.
what I realized, because if you look closely on the bottom of these, I think it's like blue and like other stuff. So I think like that, those tiny little rocks are like the power which they get or something, like the power that I can hold.
So let's fix our circuit, because we were creating a short before. Okay, so what was happening when we had the switch in parallel with everything and we closed the switch, all of the power went through here and none of it went to the bulbs. And that's why the switch wasn't working. And then what happened was our power supply detects a short, and to protect it, it cuts out. So the way that the switch should be is in series before there. Okay? So now if we connect it up. Now the switch works. Go ahead and flick the switch yourself. All right.
Ta-da!
So this is how we would wire up the circuit to have all of the bulbs all shining at about the same brightness. Now this one isn't quite as bright as the others, and we think that's just because I think this bulb has a different specification to the other bulbs. You can see it's also not quite as white. It's a slightly yellowish color.
Yeah.
So it's a slightly different specification bulb. But basically, this is how you would wire up a parallel circuit. And we can see now the amount of power we're drawing has gone way up.
97.
0.97. We're almost up to 1 amp, aren't we? So if we increase the voltage more, they're getting brighter, and as before, our amps goes up. The amount of power we're drawing goes up.
Wow, now I know that I should bring sunglasses next time.
Yeah, if we crank up the power too much, the filaments in there are going to heat up too much and they're going to melt. So we don't want to get it too bright, do we? Okay, so that's how parallel and series circuits can be put together. And we've learned a little bit about switches as well. So what we found was you don't put a switch in parallel with everything else. Because if it's in parallel, it doesn't work. It creates a dead short and nothing will power. So that's an important thing to remember when you're building your circuits, is the correct sequence that you put all of the components. All right? So now we know the difference between parallel and series circuits. And if we want to share the power and make sure that they all shine the same brightness so they all get the same voltage, put them in parallel. Okay, thanks for tuning in, and we'll see you next time. Do you have anything to say?
Don't forget to stay tuned, and don't forget again to like and subscribe. Thank you, everyone.
Bye.